Whether you are in your workplace or at your own place, you are related to somebody or something because man is by nature a social animal. Relation in mathematics is a more commonly understood idea of relations in daily life. Relations are a set of ordered pairs in which the first coordinates are thought of as inputs and comes from a set called domain. The second coordinates are considered as outputs and they come from a set called range. As we have seen, we can represent our relation in roster form and set builder form. There is one more way to express a relation in sets. Consider elements A, B, element of R. We can say A is related to B and it is denoted as ARB. We developed more detailed understanding of relations, domains, ranges and other essential notions in earlier classes. Now try to answer this question while keeping all the things in mind. Is it necessary for all sets to be related? You are absolutely correct if your answer is no. Some sets have no relation and they are referred to as empty relation. We can define an empty relation in a set as a relation where no element of A is related to any other element of A. That is, R is equal to phi subset of A cross A. Think of an example of a set containing tourist places of India. Is there any possibility of finding a relation of getting tourist places of any other country in the set? The answer is no. So, the set shows empty relation. On the other hand, if each element of a set A is related to every element of set A, then the relation is called universal relation and it is represented as R is equal to A cross A. Let W represents the set of whole numbers. Now, one of the universal relation is defined by R is equal to modulus of x minus y greater than or equal to 0. When we have the empty relation and the universal relation together, we can call it as trivial relations. Next, we will discuss another important relation, that is equivalence relation. To investigate equivalency relations, we must first explore another three different relations. Let's see one by one. A relation R in a set is called reflexive if it relates each and every element of set A to itself. Mathematically, relation R is reflexive if A, A is an element of R for every A element of capital A. In other words, A related to A for every A element of set A. To understand more, consider for instance, set A is equal to set of all letters in the word book. So, set A in roster form will be A is equal to curly brackets B-O-K. A relation R is defined as within the curly brackets ordered pairs B, B, ordered pair B, O, ordered pair O, K and ordered pair K, K. Is reflexive since all the ordered pairs lie in R. Alright. Next type of relation which we are going to deal with is the symmetric relations. A relation R on set A is symmetric if and only if an element A is related to B. Then we can say B is related to A for every A and B element of the set A. Mathematically, if A, B element of R implies that B, A element of R for all A, B element of R. we all know the addition of natural numbers is a commutative property. So, if A is related to B, we have A plus B is equal to B plus A. Therefore, B is related to A and the given relation is symmetric. Now let's look at a question. If you were told that Liam has the same mobile brand as Nitin and Nitin has the same mobile brand as David, is it safe to say that Liam has the same mobile brand as David? This isn't a tricky question, and you are safe to say that Liam has the same mobile brand as David. It is a simple logic, and the logic behind this question has to do with the transitivity. Along with the reflexivity and symmetry, transitivity is another important property defining equivalence relations. Transitive relation is one in which the first element is related to the second and second element is related to the third element. Then we can say the first element must be related to the third element, and its representation is if A comma B element of R and B comma C element of R, which implies that A comma C element of R for all A, B, C element of the set A. Now, if a relation R is reflexive, symmetric and transitive, we can say that the relation is said to have an equivalence relation. When 2 or 3 people share the same birthdays, it is reflexive, symmetric and transitive, and there arises an equivalence relation. Have you ever noticed when a person owns a car or a home, it becomes his property? Can you suggest what kind of relations happens in such scenarios? Let's look at this in the next video. Now we shall summarize the entire points covered in this section.
Manorama Horizon. Learning made simple.